Typically we'll have a team of about 6 students working on a project related to industry or research work, and they'll take a theme that is current in industry. That might be a small product that industry wants to do some trial work on, or a small aspect of a research project here at the university.
A microgrid is a power system which includes local energy storage and local energy generation systems. For example, in a home, if you're in a situation where you may lose power, if you're prone to blackouts or something like this, the microgrid, the energy storage, will enable you to continue using your appliances in the house even during these blackouts. You can introduce renewable generation systems to a microgrid without compromising dispatchable power. So if you've got a PV system, a photovoltaic system, even if you've got night time, you can still have power because you've got a battery which has stored the power from that during the summer's day.
If you look at the latest government reports on microgeneration, if we use the full capability of microgeneration in this country, we could effectively get rid of 5 nuclear power stations. Now, you can't just connect microgeneration into the network. You need extra control, you need extra hardware, you need some telecommunications. And this particular project group has been looking at that applied to a small household. So doing the modelling, building up example hardware.
Our project was about improving the system of inventorying and supply chain management by using RFID technology. And we had a few subsystems, and my communication system was meant to link the various subsystems so they could work as one system.
It was difficult. There were times where the team didn't work very well, sort of generally in the first semester. But towards the end we worked really, really well, and we put together some incredible work that I'm immensely proud of. And I can honestly say that I felt that my team worked incredibly hard. I
also enjoyed working as a team. If you've got different people working on their individual strengths, we can pull on our strengths and then produce a final system. And I think that's a great achievement which I'm very proud of.
Oh, it's been a massive insight into particularly how a project in industry can go, where you spend a lot of time scoping things, costing things, and then delays can happen, people can be off sick. There's a whole range of unpredictable things that obviously are unpredictable. And that was the realistic aspect of it that you wouldn't perhaps get with other projects.
The aim of the project was to develop a low-cost and reliable visibility monitor that could be used on the UK motorway network in both the static and potentially a mobile application. So the monitor would use the existing road infrastructure, in particular cat size, to calculate the visible range, and that data could be fed back for the static system to the Highways Agency so that they could update the gantry road signs and enforceable speed limits and warn drivers of foggy areas. And for the mobile system it would be almost like a sat-nav unit, and it would provide real-time visible range estimates and advise safe driving speeds. What you're trying to develop can be is going to be used eventually by the public, and you take the long view and you think in 10-15 years time it could be as common as sat-nav, and you're going, right, I'm helping develop this system from the start, and 10 years time I can look back and go, I developed that, I worked on that, it's something that's cutting edge. It's the first time this type of analysis has been done, so it's interesting and has great potential.
Our project was in the power labs, so we've been looking at high voltages, so looking at like 100 kV impulses, and also at AC and DC waveforms, and also looking at measurement systems for these to detect partial discharge.
Now you have aircraft like the Boeing 787 and the Airbus A350, both new planes that have much more electrical equipment on board, so they use more power. To save weight, you increase the voltage of the aircraft, and you therefore save on copper because the current levels are lower. But if you have high voltages, you've got more troubles with electrical discharge, sparks and arcs. So the equipment we had actually could simulate certain types of waveforms found on an aircraft, not just during operation, but also during lightning strikes, and we can test some aircraft components using the generator.
Kind of experience working together as a team, which is always a good thing to be able to put on your CV, but also a lot more experience writing software and working with the National Instruments equipment. It's been very useful.
I think the fourth year project for the students is something where they have a significant time to actually spend working on a real project. The third year project is good and it's important, but it's much less time in terms of the actual effort students put into it. This is a much better taste of what they will actually experience in industry.